So last time we talked about compound statements, specifically conjunctions and disjunctions. We've mentioned the conditional before, a couple class periods ago. We're going to talk a little bit more about it today. So the conditional is a statement with an if-then connective. We saw this notation, the P arrow Q, a couple sections ago. We read this as P implies Q. The P at the beginning has a couple of different names. So sometimes it's called the antecedent, or sometimes the premise. Q, the resulting statement, is called the consequent or the conclusion. And because English is so amazing, if-then statements don't always show up in order. We just don't always sort of say them that way or write them that way. And so it's often the case that we see if something, then something else, but not always. So what we're going to look at next is a couple of different statements where they are if-then statements. They're just not written that way. And we're going to rewrite them to very clearly define what the antecedent is and what the consequent is by writing it as an if-then statement. So the first one that we're going to do says, it must be alive if it is breathing. So when we have a statement that has an if in it, but the if is not at the beginning, our original piece where we are starting is with what comes after the if. So as we're rewriting this, identify where the if is, and then move it to the front. So this actually will start out with if it is breathing. And then we will land on the part that we skipped. Then, it must be alive. So sometimes it's just a matter of sort of reorganizing the structure if there's an if already present. That one okay? So that one's not too bad. The next one doesn't even look like there's an if at all in it, and there isn't. But if it is an if-then statement, or at least equivalent to one. So it says, a shopaholic has no self-control. So back up in the directions, it actually said that we may need to reorganize or add some words in. This is one where we're going to have to add some words in. There's really two descriptive pieces of information here identifying someone. One describing them as a shopaholic, and then the other describing them as having no self-control. Those are the two different statements. Does that make sense? They're not written that way, but they are two different statements. Because clearly, somebody could have no self-control in some other area, right? So those are the two pieces that we're going to be identifying. As we add our extra word or words in, keep in mind that my math lab is probably going to present this to you as a multiple choice question. So they're putting the extra pronoun or whatever it is that needs to be thrown in there to make this make sense. We're just going to give an example of one here together in class. So this starts out with an if statement, because that's what we're working with as conditionals. And we're going to say something like this. If he is a shopaholic, then he has no self-control. Does it need to say he? No. It could say he, it could say she, it could say they, it could identify a person's name. Doesn't really matter. But we're adding that extra word in there to identify it as connected to a specific person or persons. Does that make sense? Okay. We see a lot of things happen like this. They don't have to be people ones, but anytime it describes them where it's identifying these two separate statements, your goal is simply to identify the two separate statements are and then figure out what pieces have to be merged together. And again, it's usually a multiple choice type question for it to actually have the same meaning as the one before. All right, last time we also looked at this idea of changing language into symbols and symbols into language. So that's where we're headed next. So we're given three original statements. They're kind of funny. They say she has a ferret for a pet. They are terrible pets, by the way. At least they stink. They really stink bad. So if you don't like smells, don't get a ferret. The second one, P, is he trains dogs. And the third one, M, is that they raise alpacas. And we're using those same representations for both the example that takes symbols into words, which is number 3, and words into symbols, which is number 4. Okay? So I realize that on number 3, I don't even have 3 letters represented in the statement. That's okay. It's still going to represent the same things. So I do have an if-then statement because I have an arrow, right? Which means the first word that I'm going to write down is if. So it's an if statement. And then what does the representation of P stand for? Okay, so if he trains dogs. Okay, so we've finished the statement that P represents. We've come to the arrow, so we're going to include the word then. And then I need the negation of M. What is the negation of M?
They do not raise alpacas.
Yeah, so if M is they raise alpacas, this is one of those ones where it's a very simple negation. We just put the word not in, or if the word not had been there, we would have removed it. So this one is then they do not raise alpacas. If you've never seen an alpaca, it looks kind of like a llama. There's actually an alpaca farm near our house. Fun fact. All right, so I'd like for you to take a look at the next one and see if you can get some of the pieces in on your own. Same P, what was the other one? S, P, and M as before. Your statement is, if he does not train dogs, then she has a ferret for a pet or they raise alpacas. So give it your best go at what you think that the symbols might be, and then we'll connect and see that we all have the same thing. How did you start?
Negation of Q.
All right, so it's the he does not train dogs is our first statement. I'm going to kind of identify my connectives by some circles. So he does not train dogs is the negation of P. Then what? An arrow. Okay, is everybody good so far? All right, what'd you do next? We'll let Hallie take over. S.
So she has a ferret.
Okay, for the she has a ferret for a pet.
And then the V.
The V,
And then M for they raise alpacas.
Awesome. So all of that is great. There's one more thing we're going to throw in here that you wouldn't have known to do. But is everybody okay with all the pieces? Notice that we ended up with an or statement, so we have a separate connective showing up in the middle of that. All right. So this is an if-then statement. If the first part, then everything that follows. So everything that follows goes in parentheses. That all of that together combined is my then statement. Does that make sense? Okay. So cool. These are how we would change between symbols and words and be able to move between them. Okay, just like with our conjunctions and disjunctions, the next thing we're going to do is we're going to create a truth table. The truth table for this one's a little bit funny. And you'll see what I mean when we create the actual final statement. So we're going to create a truth table with just 2 statements, P and Q. All right? So 2 columns. So we have column P, column Q, and then we have our implication, our conditional P implies Q. You should know what goes in column P and what goes in column Q. We've done that already. What goes in column P?
True, true, false, false.
True, true, false, false. And what goes in column Q?
True, false, true, false.
Okay, it always looks that way. Doesn't matter what kind of statement you're doing. If you have just two statements, P and Q, these are the arrangement of the true-false parts of them. Okay, so here's the one that we're going to use. P is going to be the statement, I am a mom. And Q is going to be the statement, I am a woman.
Yay, we love Kinsey.
All right. So we're going to be looking at an if-then statement. We actually don't even need to talk about specific people. Sort of imagine that you got a text message, okay? So you have no way of knowing who this message is from. It's from a random sender, whatever. You probably would delete it, actually. But if you didn't and it said these statements, that's what we're going to think about looking at. Okay, so you get a message, and this message says, if I'm a mom, then I'm a woman. And you would say, well, yeah, and that's a true statement. No problem. Now, it feels a little bit funny for me to actually describe it this way, but anytime it says false, I'm going to use the negation of something, so it's easier to think about how to work with it. So, now let's imagine the text message said, if I'm a mom, then I am not a woman. And you'd be like, well, that doesn't make any sense. That's a false statement. Okay? Those two are usually pretty okay when people describe them in this way. We're all good. The last two are the ones that are a little bit weird. So the last two, somebody starts out by saying, if I'm not a mom, then I'm a woman. Or if I'm not a mom, then I'm a man. And you would be like, okay. Both of those could be true, right? Depends on who the person is messaging you, yeah? So what really happens is when the statement starts out false, it doesn't give you any clear indication as to what should come next. Just because the person's not a mom does not tell you anything about their gender, right? I mean, it just doesn't. So we would assume if somebody makes a statement like that to you, that they would be telling you the truth, because that statement could in fact be true in either form. So a student in my earlier class this morning noticed and made comment that both for our conjunctions, our disjunctions, and then now also for our implications, the original first two statements being true always results in a true statement. And that's true. Anytime you have true, it's a true statement. But all three of the others after that are going to change things. When we had conjunctions, we needed both statements to be true, so we ended up with a lot of false statements. When we had disjunctions, those are the or statements, we needed either one or both statements to be true, so we ended up with a lot of true statements, right? This one ends up with a lot of true statements as well, and the reason it does is because false premise at the beginning doesn't tell us anything about the result at the end, so the default position is that it's a truth statement, right? So when is an implication true? Well, the first line, obviously, it's true when everything before it comes true. And it's also true when the premise is false. When the premise is false, we automatically get a true implication statement. So we're going to do a couple of examples where we're finding truth values. So the key phrase in our directions is truth value. And they give us information about what P, R, and Q are. Okay? P and R are false, Q is true. So anytime they're asking you for a truth value and they're giving you individual PQ, T's, and F's and those kinds of things, this is one of those one-line truth tables. So those pieces of the direction are telling you you have a one-line truth table. It is still a truth table, it's just that it only has one line. Okay, so I generally go in alphabetical order. You don't have to. It doesn't really matter, but I think that my math lab will push it into alphabetical order if you don't. So you're going to have, using the letters that are given here, a column for P and a column for R. If you did it R and then P, if my math lab had it, I don't care. It doesn't matter to me if they're in the same order as mine or not, but P and R. And then I look at including any negation statements. So are there any statements here that are negated? R. So I'm going to make a column header for a tilde R. And then I think I have all the individual pieces, so the last thing is to put all of it together. On this one, there's not a lot to put together, but it is the tilde R implies P. Is everybody good so far? I usually set up all my column headers before I start doing T's and F's. You do not have to do that in that order. But they tell you in the problem what P and R are. That is to say, they tell you whether they're true or they're false. What is P? False. And what is R? False. So those are pieces of given information from the setup of the directions of the problem. Now, if R is false, what's the negation of R? True. Now, here's the unfortunate thing about the way that this is set up. My last column says that I'm going to take tilde R, which is this column, and I'm going to go backwards to P. Now, when I did statements before with conjunctions and disjunctions, it didn't matter because and or statements go either direction. So it's like addition, right? 5 plus 2 is 2 plus 5. I don't care what order I do it in. But the order matters on an implication, so we need to be careful that we're considering the column for tilde R and the column for P in the right order. That is to say, the arrow is going this direction, right? So I'm starting off with a statement here in column tilde R that's true, and I'm ending on a statement in column P that's false. So whether it is that you've just sort of caught on and you've thought through them enough to remember them or memorize them at this point, or whether you go back and you look at the truth table we created, the column we're thinking about is the column that goes T and then F. Is a true then false statement true or is it false? It's false. It's the only one that is false, actually. So the truth value, according to the last column in my truth table here, is false. This is a false statement. Now, number 6 has more pieces, okay? So I actually have 3 statements on this one, a P, Q, and R, all of them. So I have column P, a column for Q, a column for R, and then what I do is look at the individual negations next. Are there any individual negations for me to include? P. Negation of P. And then, whoops, sorry about that. Are there any compound statements besides the implication itself? Yeah, the Q. Let's do this. Q and R. And then we're actually going to label them. I did this last time. If you don't like me changing the labels, then just don't change them. You can write it all out yourself if you wish. But I called this column 1 and I called this column 2 because my last statement does an implication between columns 1 and 2. If you don't want to do that, just write the whole last column header out as tilde P arrow and then the parentheses Q and R. That's fine. It's too much writing. Okay. All right, they give you some of these. P, Q, and R. They tell you whether they're true or false. Is P true or false? Q? And R? Wonderful. So now we have the negation of P. Negation of P is true because P was false. All right, so I'll do a little bit of highlighting. I've got the column Q and the column R, and I'm supposed to join them with an and statement.
False.
That's false, because an and statement needs both statements true to be true. And then I'm going to do 1 implies 2. Well, here's column 1. That's the tilde P column. Here's column 2. It's the Q and R column. So an implication, true implies false. Is that true or is that false?
False.
It's false. So my truth value, once again, is false. I promise they're not all false. The 2 I did just were. Okay, any questions? Okay, so we did the simple one-liners first. The next ones we're going to do are actual truth tables, but we have a definition showing up before that. Tautology, a statement that is true no matter what the truth values are, is called a tautology. The way you can identify it is if you create a whole out truth table and the last column is completely all T's, then it's a tautology. Clearly, the last 2 that we just did would not have created such a truth table because both of our final column in the just my one-line one were false. One of the caveats with my math lab is that it will create questions, and it will create one much like this example where it says to construct a truth table, and then it will tell you or ask you, is this a tautology? So if you make mistakes in your truth table, it might inadvertently affect your answer about whether it's a tautology, right? You might actually get a false statement where you should have gotten all truths, and so now it's going to be off. So when we do quizzes and exams, I'll go in, I'll make sure that your tautology answer corresponds to whatever you did with your work above. Inside of the homework, it doesn't do that. It's just going to tell you there's some wrong pieces and have you redo them. So you'll redo those until you've gotten to the point where it's correct or you've used up all your attempts potentially. But this one has how many statements? Just 2 statements. It looks kind of like it's 3, but the number of statements is the individual different letters, not just negations of letters, right? So there's really only 2 statements here, P and Q. So we're going to create our truth table. So it only has 2 columns that are labeled the P and the Q. We've already done a truth table today with just 2 statements, P and Q. So I know that you've recently seen it. What are in the P column, what are the T's and F's that I need to write down? Right, true, true, false, false. And in the Q column, what do I write down? Right, they oscillate, true, false, true, false. And it always looks like this when I have 2 statements. All right, so let's get our column headers now. I skipped that, getting them all in there because I wanted to remind you the T's and the F's. But column headers, do I have any negation statements? Yes. I have a tilde P. Do I have any compound statements? Yes. In the parentheses, I have a tilde P implies Q statement, which I'll call number 1. And then what do I have? The whole thing. I have that number 1 that I just identified implies Q. So we're going to have some backward stuff going on in this table too, unfortunately, but we'll be okay, I promise. All right, let's do the first column that I haven't filled in so far. It's the easiest one. I've got a negation of P. So what will the T's and F's be in the negation of P column or the tilde P column? False, false, true, true. Just flip everything in the P column, right? All right. Now, it asks me for column tilde P arrow Q that I've labeled number 1 to take the tilde P and to take Q, but I'm going backward, right? And order matters when I'm working with implications. So we'll go carefully, one at a time. This first row in the tilde P column is false. False implies true. Is, remember?
True.
It's true. Anytime the statement starts out false in an implication, it's a true statement, which means my second row has the same feature. False in the tilde P column, and this one's false in the Q column, and that statement would also be true. Row 3, I've got the 2 T's. Right, true implies true. Okay, for all of our compound statements, whether it's conjunctions, disjunctions, or implications, that's a true statement. And the last one, I've got true implies false.
False.
That's false. Okay, it takes practice to remember which one's which, or having it there with you to refer back to is fine too. Okay, we have one more column. This is column 1 implies column Q. So these are my columns. And again, I'm going backward, right? Okay. So row 1 in the tilde P arrow Q column says true implies true. That's true. Right? True implies true is always true. The second one says true implies false. That one's false. The third one says true implies true. True. And the fourth one, false, implies false. That's true. Well done. We're going to answer the question because there'd be a blank for it to be there. And if you go back up to the directions, it asks you to identify if it's a tautology or not. And the answer is no. This is not a tautology. And again, what are you looking for? Final column of all truths. And this one doesn't have that. So it's not a tautology. Excellent. Okay, so we're going to make another table that's a little bit bigger. How many individual statements do I have in number 8? 3. These are our bigger truth tables. So I'm going to have a column for P. Again, I just go in alphabetical order. A column for Q and a column for R. Let's go ahead and fill in the rest of our headers. Any negation statements? Q. So we'll do a tilde Q column. Okay, any compound statements? Basically, I'm asking any parentheses that we have to consider. Yes. There is a P and tilde Q. And anytime I've got a column with compound statements, I usually give it a number to reference later. Column 1. Anything else we need before we do it all together? No. The last statement will be everything. It is R implies 1. Is everybody good on the column headers? Okay. You guys did a really good job remembering that a statement having, or a problem having 2 statements created the T's and F's in this order, right? TT, FF, TF, TF. Do you remember what happens when you have 3 statements? My earlier class had no clue. Not sure?
For P is the first 4 true and second 4 false.
Yeah, that's a good start. Thanks, Bailey. So the first 4 are true. And then the last 4 are false. Any ideas on the second one then? Yeah, the second column ends up kind of looking like an expanded version of column P from the previous slides. True, true, false, false. True, true, false, false. How about the third column? Yeah, they oscillate in that third column. True, false, true, false, true, false, true, false. And again, the reason that they are this way is because this includes all combinations. And that way, all combinations on my screen looks like all combinations on each one of your papers, right? It's just an ordering to make sure we capture them all, don't duplicate something and leave something out. That kind of stuff. Okay, is that good? All right, so those are always going to look like that when we have our 3 statements. We'll have 8 rows, 2 cubed, right? 8. All right, our next column is a very straightforward one to do. It's the negation of Q. So what will the negation of Q be with T's and F's?
False, false, true, true, false, false, true, true.
Right. So we're going to simply reverse the Q column. So false, false, true, true, false, false, true, true. Okay, what do we think? So far, so good? All right. So we're going to then look at the one that I've labeled number 1. It's P, which I'll highlight, tilde Q, which we'll highlight. And it's an and statement. When is an and statement true?
When both are true.
When both are true. So on the first row, I have true, false.
False.
The second row is also true, false. The third row is true, true. The fourth row is true, true. The fifth row is false, false. The sixth row is false, false. The seventh row is false, true. And the eighth row is false, true. Lots of false statements when we have and statements. Yeah? Most of what I just wrote down was false. And then we're going to look at the implication. And lucky for us, the implication actually goes from left to right in order this time. I've got my R column, and I've got my P and tilde Q column. So I'm actually going in this order from left to right on my yellow columns. Okay, so remember, implications, that's the new one. The conditional and the if-then statements, right? All means the same thing. True implies true, that's true. And false implies anything is true. So on the first row, it's true implies false. That is false. The second row is false implies false. That's actually true, right? False implies anything's true. The third one is true implies true. And the fourth one is false implies true. Also true. Okay, implications generally have lots of true statements resulting, just like or statements do. All right, fifth row, I have true implies false. And then I have false implies false. Row 7 is true implies false. And row 8 is false implies false. All right, is this a tautology? No. I promise some of them will be. Just not the ones I chose. Not a tautology. Okay, any questions on any of those? Okay, that's our last truth table, I believe, for today. The other two things that we're going to take a look at is other ways we can see implication statements written with ands and ors. Okay? So the first one is actually talking about the negation. So we saw something called De Morgan's laws last time, and it talked about the fact that if we negate and statements and or statements, we negate all these three little pieces in between. The negation works a little bit different for an implication. So we're looking at the negation of the implication P implies Q. And our question is, what does that become? So let's think for a moment. If I made a very simple statement like, if it is cold, then I wear a coat. What would have to be happening in order for that statement to not hold? For it to not be true? Well, it would have to be cold and you would be not wearing your coat, right? That would create the statement. That would be the counter example, right? That'd be my son. It's cold outside and he's still just adamantly not going to wear it. I have a picture of him from a couple years ago wearing shorts and it was 28 degrees when I dropped him off at school. Couldn't convince him otherwise. Okay, fine, wear shorts. So the negation, right, when it fails to hold true is when the implication part's holding, right? It is in fact cold and you didn't put the coat on, right? So you failed to actually do the then part. The if part was true and the then part was false. So the negation for an implication is that P is true and Q is false. And the way that we can write that is that P stays like it is and we negate Q. And we put an and in between. So we're going to do that with a statement now. So again, anytime I see connectives, I kind of put them in circles, and then I'll underline my individual statements. So my connectives are an if-then. It says Ella reaches that note, and then it says she will shatter the glass. Those are our pieces. So what I'm supposed to do with what we've written down is I'm supposed to keep the if part the same. So what's the statement in the if location?
If Ella reaches that note.
Yes, without the if. So the statement itself is simply that Ella reaches that note. But we trade the if-then for the word and. And. Ella reaches that note. And we negate what comes next. So what's the negation of she will shatter the glass?
She won't.
She won't, she will not, she did not, she does not. Whatever phrasing of it works for you is good with me. So I'll use the one you guys gave, which is she won't break the glass. That is a negation of the if this happens, then this happens. Well, the if happened, and the then didn't happen. right? It's the following through that failed. Okay, so that's a negation statement for an implication. But we also have the ability to take an implication and rewrite it as an or statement. So our P arrows Q actually has the ability to also be rewritten with the word or between them. And it looks like this: tilde P or Q. So let's just think about Ella for a moment. If I were working on this with Ella, what I would say is that Ella does not reach that note, right? She does not. That's the tilde part. Or she does shatter the glass, right? That's what it would look like if I were using that example. So I got a different example for you. Our example on this one is to simply rewrite it with the word or instead of the if-then connective. So again, here's my if, here's my then, the understood then in there, and these are my two statements. They're very brief. She doesn't and he will. Okay, so looking at the or rewrite, how will I change or what will I write down for the first part? It's supposed to be the negation of what originally was there.
She does.
She does. Okay, so I don't write if-thens. I'm going to write an or here in a moment. But the she doesn't is going to become she does. Right? Remember, negations also can remove the word not when it's in there. That's basically what's happening here. So the negation of she doesn't is she does. What's the connective I'm going to use? Or. And then I leave the second part alone. He will. So if she doesn't, he will means either she does or he will. It means the same thing grammatically speaking if we said both of those statements. Feels a little funny because we don't know what she and he are doing, but that's what's happening here with that. Any questions? All right.